Good morning, students. And now I'm going to discuss about candidate elimination algorithm. So, as we discussed in the last class about the find this algorithm, and now we are going to discuss about candidate elimination algorithm. So, what is the find this algorithm? It is going to be concentrates only on positive data. So, whenever we are going to consider the negative examples, it doesn't accept. But here, what we are going to see here, it will uses what it can use positive values as well negative values. So that is the basic difference between candidate elimination algorithm and find S algorithm. So right, and next we are going to see, the here we are going to discuss about hypothesis. The so whatever, suppose I am going to consider the concept iPhone. So here what we are going to see, the models, iPhone models like 5s, 6s, 7s, 8, 11 plus, like this some models are there, yes or no? And whenever we are going to consider, so the training data, so what is the training data? I am going to add some 11 plus and 8 plus, like 7s. So if these training data is available or not, so that we are going to verify with respect to training data should be our hypothesis space. So with respect to hypothesis space, whether the data values are available or not, so that we are going to verify. So if the data values are available, then that is the version space. So here what we are going to consider, so version space can be, so suppose for example I am going to consider most specific and most general. So how to represent the most specific? So this pi symbol is used for specific and question mark symbol which we are going to be used for general. So here this is the most specific. I am going to initialize the most specific S0, so that is with pi, and I am going to generalize or initialize, so Z0 most generalized. So how to use question mark, and here I am going to draw like this. So whatever the data points which are available between these, this is treated as version space, right? So here we can move from most specific to most general to most specific. Okay, here the hypothesis concept is going to be defined with the help of concept. Hypothesis data is going to be defined with the help of concept. So this is the what we can call candidate elimination algorithm. So in this, what you are going to concentrate, it is going to be use negative values and positive values. And here what we have to concentrate, one is version space and specific hypothesis and general hypothesis. So it is going to consider both the values. So we have both specific and general hypothesis. For a positive example, what we are going to do, so here I am going to consider, suppose if you are going to deal with for a positive example, then what we have to do, so we tend to generalize specific hypothesis. Suppose for a negative example, already told you, so it is going to deal with positive and negative data is our data. So we tend to, what we can do, we tend to make, what we have to make, general hypothesis to specific hypothesis. So if it is a positive example, what you have to do, general to specific. If it is a negative example, then specific to, right. If it is a positive example, generalizing the specific, that means specific to general. And if it is a negative example, general to specific. General to specific. So that is the thing we are going to see. So what we have to do, initialize the data. So first thing is so S0 deals with more specific. How can we represent the more specific? With the help of pi. And how can we represent the general? With the help of question mark sign. So this is the way we are able to represent the specific data and generalized data. So here, if you are going to consider the algorithm, so what is an algorithm? So coming to algorithm, so I am going to write about the algorithm. So copy this algorithm. So what we are going to do? So the first step. So if it is an algorithm, what you have to write? Step 1. So what is the step 1? Initialize. Initialize. What we have to initialize? G and S. G and S as most general and specific hypothesis. Most general and specific hypothesis. For each example, next step 2, what we have to do in the step 2? For each example, if E is positive, then what we have to do? Make specific hypothesis. Make specific hypothesis more general. That means specific to general. Else, suppose if the example is negative, then what we have to do? Make general hypothesis more specific. Observe carefully. If you are going to deal with positive example, then what we have to do? So we have to specific hypothesis more general. If you are going to deal with negative, then general hypothesis more specific. So this is the candidate elimination algorithm. So if you are going to discuss about example, then it is easy for you to understand the concept. So here, what is the concept I am going to take? The concept is, so days. What we are going to take? Days on which person enjoys sport. So that means on which days the person is going to enjoy the sport activity. So that we are going to see with some following data. So if you consider this example, what we are going to see, so here we have a table, so which we are going to have 1, 2, 3, 4, 5, 6, 7 attributes. Among the 7 attributes, the last one will be the classifier. Yes or no? So here we are going to have 2 classes. One is S class and another one is no class. S is represented with the help of positive and no is represented with the help of negative. And here this classifier is going to be influenced by these 6 attributes. What are they? Sky, temp, humidity, wind, water, forecast. The sky is going to have the values like sunny, rainy, sunny, and the temperature is going to have the values warm and cold, and the humidity is going to have the values normal and high, and the wind is going to have the values strong, and water is going to have the values warm and cool, and the forecast is going to have the values same and change. Right? So these are, how many records are there? 4 records are there. Yes or no? So here let's see the for one by one. So here I am going to see one thing. So what is that? First, so S1. So first, what you have to do? You have to initialize the and specific and general. So how can we initialize? So with more specific. So how many attributes are going to influence? 6 attributes. 1, 2, 3, 4, 5, 6. And most general one is 1, 2, 3, 4, 5, 6. So this is the way, the first step. And what is the second step? What we have to do in the second step? So that we need to define the second. So what is the second one? So that is the first record. What is the first record? As it is. So more specific to general, right? More specific to general. So why more specific to general? So that is first one is S. What we have seen in the S indicates positive. Yes, what the S indicates positive. So if it is a positive, what we have written in the algorithm. So see there, make specific hypothesis more general. Make specific hypothesis more general. So here, what I'm going to do, just I'm going to write. So what I'm going to write? So S1 equals to sunny. S1 equals to sunny, warm, normal, strong, warm, same. Right? So this is the record from first one. Sunny, warm, normal, strong, warm, same. So just I am going to make specific to general. So what is about G1? So G1 will be the as it is. 1, 2, 3, 4, 5, 6. Okay. And next, what we have to do? S2. Second record. So what is S2? S2, let's see the S2. So sunny, same, warm, same, high, normal. So there is a collision. So in S1 normal, here high. So what we have to do? So here, whenever we are going to have a different value, what we have to do? So sunny, warm, and whenever we are going to see there is a difference value, then we need to replace with general. So why? Because so it is also positive. So that is, so if it is a positive, specific to general, and then strong, warm, same. So remaining are same. Strong, warm, same. If you want, you can check it out. So sunny, warm, normal, high is the only difference. Strong, warm, strong, warm, same. So all are same. Only the difference is here. So what we have to do here, we need to replace specific to general. So how can we do the specific to general? By replacing with question mark. Yes or no? And then next, so what we are going to see with S3. So in case of step 3, what we are going to do, we are going to define the S3. So again S3, okay. So what I am going to do, sunny. So just to remember, so S3 is, what is S3? No in the sense negative. So if this is also positive, this is also positive, this is negative. So if it is positive, we need to change the specific thing, and if it is negative, we need to change the general thing. So what we have to do here, as it is, whatever the data S2 is going to have, that will be written here. So sunny, warm, next question mark, strong, warm, same. So this is S3. And what about G3? So G3 is here. What is G2? G2 is same as it is. Question mark. Okay. And what is G3? G3 will be, here it is sunny. What about first row? Rainy. So here it is rainy. Here it is sunny. So there is a difference. For each and every difference, you need to take one separate criteria. So that is, what is the difference? Sunny is the difference, and remaining 1, 2, 3, 4, 5. Okay, this is closed. And second record, what is the difference? Just go to that, and where it is difference, here it is cold and it is warm. Again there is a difference. So actually what it is in the first record, warm. So where it is? So first record, sunny, that is same, and warm. Here what you have to write? Warm. 1 2 3 4 5 6. This is closed. Go back, and where you find the difference? This is same, this is same, this is same. Here it is the difference. Here it is same, it is change. 1 2 3 4 5 6. So what you have to do? Here 1 2 3 4 5, and the sixth one will be the same. Okay, this is about what it is, G3. And now I am going with the fourth step. What I need to define? S4. How to define the S4? Again, it is a positive. What it is? Positive. If it is a positive, specific name is going to be changed. Okay, well, again we are going to compare. It is sunny. Okay, no problem. Warm. Okay, and already third one is generalized. It is a strong, and here it is cool, and it is change. If you are going to compare with more specific, what are this? This is the more specific, right? This is the more specific, right? And this more specific is going to be compared with our fourth record. Then what is going to be happen? See here. What is going to be happen? Sunny, and then warm, question mark, strong. Here it is warm and same. But what it is in the fourth record? So if you go to the fourth record, there is cool and change. So here what you have to do? Here you need to generalize cool and change. Clear? And how to define the G4? G4 is similar to G3, but the only difference is here in case of earlier one, so the warm is what is warm and same. So these are here, these warm and same are going to be generalized. So here it is the same is there, but the same is going to be generalized. So here, so this based on that, what we have to do? So here we need to consider sunny. So that is same. 1 2 3 4 5 question marks. And the second one is also warm. So that is also same. Warm. 3 4 5 6. But the third one, so what is that? The difference is same, but here it is already replaced with general. So this is going to be removed. So this will be the S4 and this will be the G4. This will be the S4 and this will be the G4. So now what we can do? So what is S4? S4 equals to sunny, warm, question mark, strong, question mark. So this is the S4. And what about G4? G4 equals to sunny, 1 2 3 4 5, and then question mark, warm, 3 4 5 6. So this will be the G4. So what is the version space? If you are going to take the version space, what we are going to see, and here I am going to get sunny, 1 2, strong, 1 2, and then sunny, warm, 1 2 3 4, and again generalized, warm, generalized, strong, question mark. So this will be the version space. Here what I am going to do is these three records as well. this is the final output. So this is about candidate elimination algorithm. So I hope this is everything is clear. So once again I'm briefing out, listen carefully. So it is going candidate elimination algorithm deals with the most specific to most general. So we have to initialize the most specific and most general, and in between most specific and more general will be treated as version space. And here what we have to do, it will be useful for positive example and negative example. So here whenever we are going to consider the positive, we need to turn general to generalized specific thing, and whenever we are going to deal with negative example, we need to make general hypothesis to specific. And the algorithm is, first step is initializing the G and S, and whenever we are going to deal with the positive and negative, so what are the changes we are going to observe? So that is specific to general and general to specific. And next, if we are going to consider the example, so here we are going to consider 4 records on which the person is going to enjoy the play. So based on that concept, we are going to initialize S0 and G0. So that is the first thing. And second thing, so the first record is positive, so we need to change the specific, as it is the specific is going to be considered, and general. And the next record, what we are going to observe, there is a change in third value, so it is going to be specific to generalized, and G2 will be same. And the third record we are going to consider negative. So if it is a negative, there is no change in the specific, but only change in general. So whenever there is a collision occurs, then such record individually we are going to consider. And whenever we are going for fourth record, it again becomes positive. So if it is a positive, we need to change the specific, and here the last value is going to be generalized. So based on this, G4 is going to be eliminate the third category. So why? Because it becomes generalized. So this is the candidate elimination algorithm. Thank you.